So welcome to the class. This is the problem we will be solving in today's session. See, an object 5 centimeter in length or 5 centimeter in height is held 25 centimeter away from a converging lens. So what is your converging lens? As we have discussed in the previous sessions, converging lens is your convex lens. So converging lens is nothing but your convex lens. Alright, and it has a focal length of 10 centimeter. You should draw the ray diagram and find the position, size and the nature of image formed. So before attempting the problem, you should be thorough with the tabular column given in your textbook about the position of the object, the size of the image and the nature of the image formed. Assuming that you are all thorough with that, let us attempt the problem. This is converging lens is nothing but your convex lens. And it's it comprises of an optic center O, focal points f1 due to a lens placed on left hand side. So combining two lenses only, you are going to get a convex lens, right? So due to the lens on the f1 on the left hand side, you have a focal point f1, and on the right hand side you have f2. And also, like the center of curvature on your mirror, here also you have a curvature. You can name it as C1 or 2F1 since it is equidistant from F1, as the distance of OF1 is F1 C1, or you can name it as 2F1, and here you have 2 F2 or C2. Alright, so it is given that the object is held 25 centimeter and the focal length is 10 centimeter. So the focal length is 10 centimeter from the optic center. So what focal length they have mentioned here, it is f1 or f2 means, see, always you are going to place the object on the left hand side of the lens or mirror or whatever it may be. So the focal length they are giving here, it is clearly the focal length f1, because this left hand side is where you are going to keep the object. All right, draw the ray diagram and find the position. Okay, and where the object is held, it is 25 centimeter from the converging lens. So if you look at this, if OF1 is 10 centimeter, what will be 2F1? As the name suggests, it will be double the magnitude or double the length of your F1. So it is going to be 20 centimeters, right? And where my object is getting placed, it is going to be placed beyond C1. This is where my object is placed. Let us name it to be AB, and it is 5 centimeter in length or in height. So how the rays are going to be refracted? So we all know that, or it is given in your textbook, that the light ray passing parallel to your principal axis will get refracted through the focal point. It will get refracted through the focal point. Also, the ray passing through the optic center will follow the same path and get refracted. So it will be a straight line. So this is the incident light and this is the refracted light. Now, whereas the intersection of these 2 points is where your image is going to get formed. So this is the intersection point, and let us drop a line, and this is your image. So it is going to be A dash and B dash. So why I am naming this A dash is, it is on the same axis of your A. Alright, it is on the same axis of your A. So I am naming it as A dash, and this I am naming it as B dash. So how is your image? It is inverted, right? How is the image? It is inverted, and also it is smaller in magnitude or height, and also it is real. Always the inverted images are real. So the answer is, it is diminished, real, and inverted. We have found the position. Position means where it is located. So here it is real. So real gives the position. Real means it is always going to be on your right hand side, right? Size, the size is diminished, and nature is inverted. All right. Thank you.